Picture a night 10,000 years ago. No electric hum, no streetlights bleeding into the dark. Just firelight dancing against stone walls, casting shadows that twist and breathe like living things. Around that fire sit figures whose names have been erased by time elders, healers, builders, passing down knowledge in whispers and chants, in gestures traced against the smoke. Back then, the world had no textbooks. Power came without equations. A person who could predict the flooding of rivers, who knew which plants could kill or cure, who understood how to align stones with the stars. That person held something the community needed to survive. Call it wisdom, call it craft. The people of that time might have called it magic. But what if it wasn't? What if the word magic is simply the name we gave to science we no longer understood, a placeholder for technologies and techniques that slipped through the cracks of history, buried beneath collapsing empires and rising seas? What if the mystics weren't conjuring illusions, but applying principles of physics, chemistry, acoustics, and astronomy that we're only now beginning to reclaim? This is not a story about fantasy. It's a story about forgetting, about how fragile knowledge is when it lives only in minds and voices, when catastrophe can erase entire generations of understanding in a single season. It is about the possibility that our ancestors were not primitive, but that we are the ones still catching up. The fire still burns. The question still hangs in the smoke. What did we lose when we stopped? In the ancient world, there was no wall between the sacred and the practical. A priest who studied the movement of planets was also an astronomer. A healer who brewed remedies from roots and resins was both shaman and pharmacist. The mason who carved temples aligned to solstices was architect, mathematician, and mystic all at once. To them, these were not separate disciplines. They were different expressions of the same unified language, the language of how reality worked. Consider the Babylonian astronomers who tracked Venus across centuries of clay tablets, recording its cycles with precision that rivals modern ephemerides. Were they worshipping a goddess or mapping gravitational rhythms? Both, the ritual and the observation, were inseparable. The incantation spoken before mixing medicinal compounds wasn't just theater, it was a mnemonic device, a way to encode dosage, timing, and procedure into memorable verse. In Egypt, the construction of pyramids required advanced knowledge of geometry, material science, and logistics. Yet every stage of the process was accompanied by ritual. The laying of the foundation stone, the alignment to true north, the placement of offerings in hidden chambers. These acts were not interruptions of the work. They were the work, woven into a cosmology that saw no difference between building and worship, between engineering and prayer. The Greeks inherited this fusion. Pythagoras taught that numbers were divine, that geometric ratios could unlock the structure of the cosmos. His followers studied mathematics with the fervor of monks, believing that understanding proportion was a path to understanding the gods themselves. Was this mysticism? Yes. Was it also the birth of mathematical physics? Also yes. The division came later, when empirical testing began to eclipse tradition, when observation replaced invocation. A wedge was driven between knowledge and belief. What once had been one river split into two streams, science and religion, reason and faith, fact and magic. But for most of human history, that division did not exist. And perhaps, in the minds of those who built the first observatories and distilled the first essences, it never should have. Believing? Centuries rolled forward, and something shifted. The old ways rooted in tradition, wrapped in ritual, began to crack under the weight of a new question. Can you prove it? The Enlightenment brought measurement, repeatability, skepticism. If an herbal remedy worked once but failed twice, was it medicine or coincidence? If an alchemist claimed to transmute lead into gold, but could never demonstrate the process to independent witnesses, was he a scientist or a charlatan? The scientific method demanded evidence that could be tested, replicated, verified by others under controlled conditions. And so the line was drawn. Practices that could be measured and repeated were elevated to the status of science. Those that relied on intuition, secrecy, or subjective experience were relegated to the realm of superstition. Alchemy became chemistry, but only after shedding its mystical language. Astrology became astronomy, but only after discarding the idea that stars influenced human fate. Herbalism became pharmacology, but only after isolating compounds and discarding the rituals that accompanied their use. Mainstream history tells us this was progress. And in many ways, it was. Empirical science gave us antibiotics, electricity, flight, computing. It stripped away layers of myth and revealed mechanisms that could be understood, taught, and improved upon. It replaced guesswork with precision, tradition with innovation. But there was a cost. In the rush to separate fact from fiction, we may have discarded knowledge we didn't yet understand. Practices dismissed as magical thinking might have contained kernels of genuine insight methods that worked, even if the theory behind them was framed in metaphor rather than mathematics. The Enlightenment didn't just illuminate. It also cast long shadows, obscuring entire categories of inquiry deemed unworthy of serious attention. History, after all, is written by those who survive to tell it. And what we call superstition may simply be the science of civilizations that didn't. The alchemists stand at the crossroads of this story, one foot in mysticism, the other in the laboratory. For centuries, they've been caricatured as deluded dreamers chasing the impossible, turning base metals into gold, discovering the elixir of eternal life, unlocking the philosopher's stone. But strip away the allegorical language, and a different picture emerges. Alchemy was the chemistry of its time. The distillation techniques alchemists perfected are still used in modern labs. The separation of compounds, the study of acids and bases, the identification of elements, all of this emerged from alchemical workshops filled with crucibles, alembics, and furnaces. When an alchemist spoke of purifying the soul of mercury, he was also describing a real chemical process, even if the language was borrowed from spiritual metaphor. Consider Jabir ibn Hayyan, the Persian polymath whose texts on distillation, crystallization, and sublimation laid groundwork for modern chemistry. Or Paracelsus, who rejected the idea that illness was punishment from the gods, and instead sought chemical cures pioneering the use of minerals like sulfur and mercury in medicine. These were not frauds. They were innovators working within the conceptual frameworks available to them. Even the quest for gold was not as absurd as it sounds. Alchemists understood that substances could transform wood to ash, grape juice to wine, raw ore to refined metal. If matter could change form, why not change nature? The error wasn't in the question, but in the limits of their tools. With particle accelerators, we can transmute elements today, though the cost far exceeds the value of gold. The alchemists were wrong about the method, but not necessarily about the principle. Yet they failed to make the leap into modern science. Why? Perhaps because their work was shrouded in secrecy, encoded in symbols to protect trade secrets and avoid persecution. Perhaps because their goals were tangled with spiritual ambitions that couldn't be tested empirically. Or perhaps because the knowledge simply died with them lost when workshops burned, when plagues swept through cities, when wars erased entire intellectual lineages. The alchemists almost changed everything. In a sense, they did. But they've been remembered as magicians, not as the chemists they truly were. Here is a fact that should unsettle any assumption of steady progress. The Romans built structures over 2,000 years ago that remain standing today, weathered by earthquakes, storms, and centuries of neglect. Meanwhile, modern concrete, our most ubiquitous building material, begins to crack and crumble within decades. The secret was in the mix. Roman concrete, opus cementitium, was made from volcanic ash, lime, and seawater. But it wasn't just the ingredients, it was the way they interacted. When seawater penetrated the concrete, it triggered a chemical reaction with the volcanic minerals, creating new crystalline structures that actually strengthened the material over time. It was self-healing concrete, growing more resilient with age. Then the Roman Empire fell. The roads crumbled, the aqueducts dried up, and the formula vanished. For over 1,500 years, no one knew how to replicate it. The knowledge wasn't written down in a way that survived, or if it was, the texts were lost in the flames that consumed libraries, in the chaos that swallowed cities. It wasn't until the 21st century, using electron microscopes and advanced chemical analysis, that researchers finally decoded the secret. The Romans had engineered a material superior to what we use today, and we spent a millennium and a half not even realizing we'd lost it. How much else have we forgotten? How many other techniques, formulas, insights into the properties of matter and energy slipped away in the gaps between civilizations? If something as fundamental as construction material could vanish so completely, what else might be waiting in the ruins, encoded in myths, or simply gone forever? The Romans didn't call their concrete magic, but to anyone who watched it endure while modern structures failed, it might as well have been. Stand inside the Pantheon in Rome, and you'll feel it a presence that transcends architecture. The dome above is a perfect hemisphere, its oculus open to the sky, light pouring down in a shaft that moves across the floor like the hand of a cosmic clock. Every proportion is intentional. The height equals the diameter. The sphere inscribed within the space touches the floor at its lowest point and the oculus at its highest. It is geometry made sacred, or perhaps sacred made geometric. This was not unique to Rome. From the pyramids of Giza to the Gothic cathedrals of Europe, from the temples of Angkor Wat to the kivas of the American Southwest, ancient builders embedded mathematical ratios into stone. The golden ratio 1.618, found in spiraling galaxies, and the chambered nautilus, appears again and again in sacred architecture. The Fibonacci sequence, the Pythagorean theorem, the precise alignment of structures to equinoxes and solstices, these are not accidents. The question is, why? One answer is aesthetic. The golden ratio is pleasing to the eye. Symmetry feels harmonious. Perhaps ancient architects simply discovered what looked beautiful and repeated it. But another possibility emerges when you consider what these structures do. The king's chamber in the Great Pyramid has acoustic properties that amplify certain frequencies while dampening others. Chartres Cathedral's rose window is positioned so that sunlight illuminates specific stones only on particular holy days. Newgrange in Ireland was built so that dawn light on the winter solstice penetrates a narrow passage to illuminate a chamber deep within the Mount de Feet, requiring precise astronomical knowledge and engineering skill. Were these temples, or were they instruments? Were the builders encoding prayers into stone, or were they constructing machines designed to focus sound, light, and perhaps other forces we've yet to name? The lines between art, science, and spirituality blur when you realize that sacred geometry might not be metaphor. It might be applied physics, hidden in plain sight. If reality operates according to mathematical laws, then shaping space according to those laws could theoretically produce tangible effects. Resonance, harmony, perhaps even phenomena we'd struggle to explain. The ancients may have understood this instinctively, even if they described it in the language of gods and spirits rather than equations. The code was always there, carved into the stone. We just stopped knowing how to read it. But here, the historians raise their hands. Wait, they say, slow down. Yes, ancient structures contain mathematical ratios, but humans are pattern-seeking creatures. We see faces in clouds, constellations in scattered stars, meaning in randomness. If you measure enough angles and distances in any large structure, you'll eventually find correlations to pi phi or the speed of light. That doesn't mean the builders intended them. It might just mean you're looking hard enough. Consider the Great Pyramid. Enthusiasts have claimed it encodes the circumference of the Earth, the speed of light in meters per second, the distance to the Sun, and the orbit of Sirius. But the pyramid was built long before meters were invented. The measurements required cherry-picking specific units and dimensions while ignoring others. Change the baseline, and the mysteries evaporate. This doesn't make the achievements any less impressive. Building a structure that massive, with stones weighing tons, aligned to true north within a fraction of a degree, that required extraordinary skill, organization, and knowledge. But extraordinary doesn't mean supernatural. It means human ingenuity operating at the highest level available to that culture. Symbolism also plays a role. When a cathedral's dimensions echo biblical numerology, it is not evidence of hidden physics, it is evidence that the builders wanted to honor their theology in stone. When a temple aligns to the solstice, it may reflect astronomical observation, but that doesn't mean the structure was designed to manipulate celestial forces. It might simply be a way to mark time, to connect the rhythms of human life with the rhythms of the cosmos. Mainstream archaeology warns against overreach, the temptation to see lost super-civilizations behind every ancient monument. To assume that anything we find difficult to replicate must have required technologies beyond what the historical record shows. Sometimes the simplest explanation is the right one. Ancient people were smart, patient, and highly skilled. They didn't need anti-gravity or alien intervention. They had time, labor, and deep knowledge passed down through generations. Yet even the skeptics admit there are gaps, things we don't fully understand, and in those gaps, questions linger. Sound is invisible, but it is not powerless. Strike a tuning fork near a wine glass tuned to the same frequency, and the glass will begin to hum, vibrating in sympathy. Increase the amplitude, and the glass shatters. Sound is energy made audible, and energy shapes matter. The ancients knew this, even if they lacked oscilloscopes and spectrometers. They knew that voices raised in unison could fill a space with resonance, that drum beats could synchronize heartbeats, that certain tones felt sacred while others felt unsettling. And so they built accordingly. In the hypogeum of Cal Saflieni in Malta, a subterranean temple carved from limestone, researchers discovered something remarkable. A chamber with acoustic properties so precise that a voice speaking within it resonates at 110 hertz. A frequency shown to alter brain activity, shifting listeners into a state of heightened emotion and suggestibility. Was this intentional? The chamber's shape suggests it was. Voices speaking at normal frequencies are clear, but at that specific pitch, the stone itself seems to amplify and sustain the sound, turning speech into something that feels almost otherworldly. Egyptian temples contain chambers with similar effects. Chanting priests would have heard their voices multiply, layered and looped by stone corridors designed to trap and reflect sound. The experience would have been overwhelming, an auditory immersion that could easily feel divine. This was not magic. It was acoustic engineering. But to those who experienced it without understanding the mechanics, the line between the two would have been imperceptible. Meanwhile, across the ancient world, incantations were not just words, they were tonal formulas. Vedic chants, Gregorian hymns, Tibetan throat singing, all employ specific frequencies, rhythms, and repetitions. Modern studies show that these patterns can alter brainwave states, reduce stress, even influence cellular activity. The words themselves might be secondary. The real power could be in the vibration, the resonance, the way sound moved through the body and the space around it. If the ancients understood sound as a force capable of affecting both mind and matter, then what we call incantations might have been early experiments in applied acoustics. Not spells, protocols. Not magic, just science we forgot was science. Scattered across Wales, Ireland, and parts of Scotland are stones that should not exist, at least not according to conventional geology. These are ringing stones, boulders and rock formations that, when struck, produce clear, resonant tones like metal bells. Some produce a single note. Others create harmonics, layered pitches that shimmer in the air long after the strike. Geologists call them phonoliths, from the Greek for soundstone. The effect occurs when the internal structure of the rock allows it to vibrate with minimal damping. But while the science explains how they ring, it doesn't explain why ancient people moved them, arranged them, and built monuments around them. At Ringing Rocks Park in Pennsylvania, a field of boulders covers several acres. Strike one and it chimes. Strike another and the tone differs. Some produce no sound at all, despite appearing identical. Indigenous oral traditions speak of these rocks as sacred, as places where the earth itself could sing. Were these natural curiosities, or were they instruments? Some researchers suggest that ancient cultures used ringing stones in ritual, striking them in sequences to create rhythms and melodies. If so, then these sites were not just temples, they were performance spaces, designed to merge landscape and sound into a unified sensory experience. And then there are the structures themselves. Stonehenge, Avebury, and other megalithic sites often incorporate stones with unusual acoustic properties. Some amplify sound. Others seem to absorb it, creating zones of eerie silence. Whether by accident or design, these places manipulate the auditory environment in ways that would have profoundly affected anyone standing within them. We build concert halls with carefully calculated acoustics, shaping sound with precision. The ancients did the same with stone, with landscape, with spaces carved from bedrock. They didn't need microphones or amplifiers. They had the earth itself, and they knew how to make it sing. Open the Edwin Smith Papyrus, an Egyptian medical text dating to around 1600 BCE, and you'll find something startling: a surgical manual. It describes procedures for setting broken bones, suturing wounds, even treating traumatic brain injuries. The language is clinical, methodical. There are no prayers to gods, no magical incantations, just observation, diagnosis, and treatment protocols. This was not primitive guesswork. This was medicine. Elsewhere in the ancient world, similar knowledge surfaces. The Sushruta Samhita, an Indian text from roughly the same period, describes over 300 surgical procedures, including rhinoplasty, cataract removal, and caesarean sections. It details the use of specialized instruments, scalpels, forceps, needles, and even discusses the importance of sterilization using boiled water and smoke. In the Americas, the Inca performed successful trepanation, drilling holes into the skull to relieve pressure or remove bone fragments with survival rates that rival modern standards. Archaeological evidence shows that patients lived years, even decades, after these surgeries, their skulls showing clear signs of healing. And then there are the pharmacies. Opium for pain, willow bark containing salicylic acid, the precursor to aspirin for inflammation, digitalis from foxglove for heart conditions, Artemisia annua, used in traditional Chinese medicine, which modern science has confirmed contains artemisinin, a potent antimalarial compound. These weren't folk remedies stumbled upon by accident. They were the result of centuries of observation, experimentation, and refinement. Yet when European colonizers encountered indigenous medicine, they dismissed it as superstition. Herbal cures were labeled witchcraft. Shamans were persecuted. Knowledge systems that had sustained entire civilizations were erased, burned, or driven underground. Only now, as modern pharmacology revisits these traditions, are we beginning to realize what was lost. Compounds isolated from plants used by indigenous healers are becoming the basis for new drugs. Surgical techniques described in ancient texts are being re-examined and, in some cases, readopted. The magic was real. It was just medicine in a language we'd stopped speaking. Knowledge is fragile. It lives in minds, in voices, in the hands that shape clay and stone. It can be passed from teacher to student, elder to child, preserved across generations until the chain breaks. And the chain breaks more often than we'd like to believe. Around 12,800 years ago, The Earth entered a period known as the Younger Dryas, a sudden, brutal return to Ice Age conditions that lasted over a millennium. Temperatures plummeted, glaciers advanced, megafauna went extinct. Human populations, which had been expanding and diversifying, contracted sharply. Settlements were abandoned. Trade networks collapsed. If there were sophisticated cultures during this time, groups with advanced knowledge of astronomy, agriculture, or engineering, they would have been devastated, not just by cold, but by the cascading failures that follow climate collapse: drought, famine, conflict, migration. Knowledge held in oral tradition would have been lost when elders died without successors. Libraries, if they existed, would have been left to rot or burn as communities disintegrated. This was not unique. The Bronze Age collapse around 1200 BCE wiped out entire civilizations in the Mediterranean and Near East. Palatial centers fell. Writing systems were forgotten. Trade routes vanished. It took centuries for the region to recover, and much of what had been known was simply gone. The same pattern repeats across history. The burning of the Library of Alexandria, the collapse of the Maya, the depopulation of the Americas following European contact, which wiped out an estimated 90% of the indigenous population, and with them, millennia of accumulated knowledge. Each catastrophe is a bottleneck. Each time, humanity rebuilds, but not from the same starting point. We climb the mountain again, but we take a different path, and some peaks are never reached a second time. If ancient science existed, it would have been vulnerable to precisely these kinds of events. Knowledge that wasn't written down would vanish with its keepers. Knowledge that was written might be destroyed or rendered incomprehensible if the language died out. And so the record gaps become silent, and we're left guessing what once filled the void. Climate didn't just shape civilizations. It erased them and took their secrets with them. Archaeology is the science of what remains. And most things don't. Organic materials, wood, cloth, leather, paper decay within decades or centuries at most, unless preserved by exceptional conditions like desiccation, freezing, or oxygen-free burial. Stone and metal endure, but they're silent. A bronze tool tells you how it was made, but not how it was used. A carved stone gives you a date and a location, but not the thoughts of the person who shaped it. This creates a bias in the record. We find what survives, and we build our understanding of the past around those fragments. But what about knowledge that left no physical trace? Consider oral traditions. For most of human history, knowledge was transmitted through storytelling, song, and ritual. These traditions could be extraordinarily precise. Aboriginal Australians preserved navigational and ecological information for tens of thousands of years without writing. But once the chain of transmission breaks, the knowledge is gone. No artifact remains. No ruins testify to its existence. Mainstream archaeology acknowledges these gaps, but it also insists on evidence. Without physical proof, speculation remains just that, speculation. Claims of ancient high technology or lost civilizations require extraordinary evidence, and so far, that evidence hasn't materialized in forms the discipline can accept. Yet the gaps are real. There are structures we can't explain with the tools we assume are available. There are maps that depict coastlines as they appeared thousands of years before modern cartography. There are astronomical alignments that required generations of observation and mathematical sophistication. The standard response is that ancient people were smarter and more capable than we often give them credit for. And that's true. But it is also possible that the record is incomplete, not because we haven't dug deep enough, but because what we're looking for dissolved into air and earth long ago. Absence of evidence is not evidence of absence, but it's also not evidence of presence. We're left in a peculiar position, unable to prove that lost knowledge existed, but equally unable to prove that it didn't. The gaps remain, and in those gaps, the questions linger. In 1513, an Ottoman admiral named Piri Reis compiled a world map, drawing on older sources that have since been lost. The map shows the coastlines of Europe, Africa, and South America with remarkable accuracy for the time. But there's a problem. The southern portion depicts the coast of Antarctica without ice. Antarctica wasn't officially discovered until 1820. The continent has been buried under ice for millions of years. Yet the Piri Reis map, and others like it, appear to show coastal features that would only be visible if the ice were gone. Skeptics argue the map is simply inaccurate, that the landmass depicted is South America distorted by projection errors. But researchers who've analyzed the map note correspondences that are difficult to dismiss. If Piri Reis was copying from earlier sources he claimed dated back to the time of Alexander the Great, then where did those sources get their information? Another example, the Orontius Phineus map of 1531, which also shows Antarctica, this time centered at the South Pole with mountain ranges and river valleys that match the subglacial topography revealed by modern ground-penetrating radar. These are not isolated curiosities. The Zeno map of 1380 depicts Greenland with accuracy that wouldn't be matched until the 20th century. The Dulcert Portolan of 1339 shows the Mediterranean and Black Sea with such precision that it appears to have been based on trigonometric surveying, a technique not supposedly developed until centuries later. How? One possibility. These maps were copied and recopied from older sources, degrading slightly with each iteration, but preserving information from a time when sea levels were lower, or when explorers we have no record of traveled further than we know. Another possibility. Coincidence and retroactive interpretation. Humans see patterns where none exist, and it's easy to project modern knowledge onto ambiguous old drawings. But the third possibility refuses to go away, that someone, at some point, knew more about the world than they should have. And that knowledge, fragmented and misunderstood, survived in maps that cartographers copied without comprehending their source. The stories are remarkably consistent across cultures. Beings descend from the sky or emerge from the sea, bearing gifts, tools, laws, instructions for building, planting, organizing society. They teach humanity the arts of civilization, and then they leave or die or ascend back to the heavens. In Mesopotamia, the Apkallu are fish-like figures who bring wisdom to humanity before the flood. In Egypt, the god Thoth is credited with inventing writing, mathematics, and medicine. In Mesoamerica, Quetzalcoatl is the feathered serpent who brings agriculture, astronomy, and the calendar. In Greece, Prometheus steals fire from the gods and gives it to mortals, along with the knowledge of craft and science. These myths could be purely symbolic humanity's way of explaining the origin of culture and technology by attributing it to divine intervention. Fire wasn't invented, it was stolen. Writing wasn't developed, it was revealed. But another reading is possible. What if the gods were human exceptional individuals, perhaps survivors of an earlier, more advanced society, who appeared to less developed cultures as figures of immense power? They would have possessed knowledge that seemed magical: metallurgy, astronomy, agriculture, architecture. They might have been venerated, mythologized, and eventually deified as the memory of their true nature faded. Consider the cargo cults of the Pacific, where islanders who encountered modern technology during World War II began to build imitation airstrips and radios from wood and straw, hoping to summon the planes that had brought goods. Within a generation, the story could shift. The planes become gods, the soldiers become divine messengers. Fast forward 1,000 years, and the cargo cults become mythology. If a catastrophe wiped out a technologically advanced culture, and a few survivors carried fragments of knowledge to distant, less developed regions, they would be received as teachers, as heroes, perhaps as gods. Their instructions, how to align a structure to the stars, how to smelt metal, how to irrigate fields, would be passed down, ritualized, and eventually mythologized. Were the gods metaphors? Engineers? Or simply the echo of knowledge that arrived from somewhere else, carried by people whose names and faces were replaced by symbols and stories? The texts remain, the stories endure, and the question hovers between history and myth. In 1936, workers excavating near Baghdad unearthed a clay jar, roughly 2,000 years old, containing a copper cylinder and an iron rod. When filled with an acidic liquid vinegar, wine, or citrus juice, the jar produces a measurable electric current. It's been called the Baghdad Battery, and it shouldn't exist. Or rather, it shouldn't function. The orthodox view is that ancient people had no knowledge of electricity. Yet here is an object that behaves exactly like a galvanic cell, a primitive battery. Skeptics argue it was used for something mundane, storing scrolls, holding offerings. But experiments have shown that when connected in series, several of these jars could produce enough voltage to electroplate. Metal, a technique used to coat objects with a thin layer of gold or silver. And indeed, artifacts from the same period have been found with gold plating too thin, and even to have been applied by hammering or leaf application. Electroplating offers a cleaner explanation. If the Parthians or Babylonians understood electrochemistry, what else did they know? Did they experiment with it further? Did the knowledge die with the individuals who discovered it, leaving only a handful of jars as silent testimony? Elsewhere, the evidence is more ambiguous, but no less intriguing. The dendrolite, a carving in an Egyptian temple, depicts what some interpret as an enormous bulb containing a serpent connected to a box that resembles a power source. Mainstream Egyptologists see it as symbolic, the serpent representing the sun or a deity. But the resemblance to a Crookes tube, an early electrical discharge lamp, is uncanny. And then there are the electroplated artifacts from pre-Columbian South America. Gold-plated copper objects that show no signs of mechanical application, leading some researchers to suggest that indigenous cultures independently discovered electroplating. Electricity is invisible. It leaves no ruins. If ancient people experimented with it in limited ways, small-scale plating, illumination, novelty effects, those experiments would vanish with the knowledge. A battery corrodes. A bulb shatters. Without a theoretical framework to preserve the principles, the practice evaporates. We know the Greeks described naturally occurring static electricity and magnetism. We know the Egyptians had access to copper, acids, and enough metallurgical knowledge to craft intricate jewelry. The components existed. The question is whether they were ever assembled and what was done with them if they were. Electricity before wires, batteries before Edison. A flicker of understanding, lost in the dark. Imagine the fall. Not all at once, but slowly, over generations. A city that once gleamed with temples and workshops now stands half empty. The engineers who understood the aqueducts have died, and no one trained their successors. Water still flows, but when the channels crack, no one knows how to repair them. Within a few decades, they're dry. The priests still perform the rituals, chanting the old words, striking the gongs at the prescribed times. But they no longer remember why. The ritual was once part of a larger system astronomical calculation, acoustic resonance, communal coordination. Now it's just tradition. The meaning has evaporated, leaving only the form. In the library, scrolls gather dust. The language is shifting, and the old script is hard to read. A young scribe copies a text on metallurgy, but he doesn't understand the symbols for temperature or proportion. He does his best, but errors creep in. A century later, the copy is copied again, and the errors multiply. Eventually, the instructions are incomprehensible, and the scrolls are discarded or burned for warmth. This is how science becomes magic, not through mystification, but through forgetting. A technique that once had a clear, repeatable procedure becomes a half-remembered ritual. A formula encoded in verse becomes a prayer. A tool whose function was understood becomes a sacred relic, its purpose obscured by reverence. The knowledge doesn't vanish instantly. It degrades, like a signal passing through too many intermediaries, until what remains is noise. The descendants still perform the rites. They still build the altars, light the fires, speak the words. But the why is gone. If you ask them, they'll say, because the gods command it, or because this is the way it has always been done. And in a sense, they're right. It has always been done this way, because everyone who knew the original reason is dead. This is the tragedy of lost knowledge. It doesn't disappear. It transmutes. What was once clear instruction becomes myth. What was measurable becomes mysterious. And future generations, encountering the fragments, call them magic because they've lost the key. The fire still burns. The stones still stand. But the language that explains them is silent. There is a curious symmetry in modern science. The deeper we probe into the nature of reality, the more we encounter ideas that sound like ancient mysticism. Quantum mechanics tells us that particles exist in superposition, that observation collapses probability into actuality, that the universe is fundamentally uncertain. The mystics said something similar, that reality is illusion, that consciousness shapes existence, that the observer and the observed are not separate. The Greeks spoke of atoms' indivisible particles that compose all matter. Democritus guessed the structure of reality 2,400 years before we could prove it. The Vedic texts describe cycles of creation and destruction spanning billions of years timescales that match modern cosmology more closely than the biblical thousands. Tesla spoke of frequency and vibration as the keys to understanding the universe. Ancient traditions from Egypt to Tibet said the same. That sound, rhythm, and resonance are fundamental forces shaping existence. Are we rediscovering what was once known? Or are these just coincidences, the inevitable result of humans asking the same questions across millennia? Perhaps both. The questions are universal. The methods differ. The ancients worked through observation, intuition, and metaphor. We work through experiment, measurement, and mathematics. But the territory we're exploring may be the same. There's also the possibility that knowledge is cyclical. Civilizations rise, accumulate understanding, then collapse. The next wave builds on fragments, climbs partway back, then falls again. Over deep time, humanity might have approached certain insights multiple times, articulated them in different languages, then lost them and had to start over. If that's true, then progress isn't a straight line. It's a spiral circling back to old truths dressed in new terminology. We've rediscovered Roman concrete. We're rediscovering herbal medicine. We're beginning to take seriously the idea that consciousness might be more than an epiphenomenon of neurons firing. We're exploring the power of sound to alter matter, the structure of sacred geometry, the possibility that ancient texts contain encoded knowledge we're only now learning to decode. We call it progress, but it might also be remembering. The fire burns low, the shadows lengthen, and we're left with a question that has no easy answer. If magic was lost science, if the mystics were engineers, if the rituals were protocols, if the myths encoded real events and real knowledge, then what does that mean for us? It means knowledge is more fragile than we think. We believe we've recorded everything, digitized it, backed it up in servers scattered across continents. But servers fail, languages drift, formats become obsolete. In 1,000 years, will anyone be able to read our files? In 10,000, will they even know we existed? It means that progress is not inevitable. Every generation inherits the world shaped by the one before, but inheritance can be interrupted. War, disease, climate collapse, any of these can sever the chain. And when the chain breaks, the climb begins again from a lower place. It means we should be humble. When we encounter ancient structures we can't fully explain, when we find techniques we struggle to replicate, when we read myths that echo scientific principles we vow only recently formalize, Perhaps we should resist the urge to dismiss them as primitive.